When we look at the general water cycle, it's really important to understand that we have the ability to change, manipulate, and benefit the water cycle. One of the biggest questions I get very often when we have people who are asking about swales and how, well, okay, if you're building a water harvesting structure that is capturing the rainwater and then putting it in a pond, aren't we depriving these rivers and streams and lakes from their water supply? So it's important to understand how the water cycle is affected by a swale in a pond because it's very much mimicked. These systems, again, are designed after nature, and so they mimic natural processes. When we look at, for comparison, forested headwaters, so headwaters are the area around the top of a river system. So there's little rivers, little streams that all feed together into bigger rivers that figure together into a big river out to a lake or an ocean. So those headwaters of those tributaries, the small streams, if they are forested and we have a torrential rain, which with climate change we're getting more and more intense rainfalls rather than longer rainfalls, which is what we used to get. We're getting instead like a torrential downpour. You may have noticed this in the last few years. And so it's a lot harder for soils to absorb that unless you are the trees, right? Which is a common exception that we're going to be talking about throughout this entire course, right? Many, many standards, and then except if you're a forest. So in the forest situation, massive torrential rain happens, the branches slow down that rain, it trickles and washes through the forest and is absorbed by the massive soil sponge and organic matter sponge below. It then goes into the groundwater, and the groundwater is actually a visual, or the river is a visual expression of the groundwater. So the groundwater is there a little bit higher up than where the river is. And so the groundwater table rises as the soil is infiltrated with rainwater that's absorbed by the forest. So the river level will slowly rise. It won't be like a flash flood. It'll be a general overall increase in the level of the river, which means a general overall increase of the level of the lake as well. Now, contrarily, if you look at a city that's by a river, or a subdivision by a river, or a farm by a river, the water when it lands has no absorption. 1% of the water is absorbed in the city. I don't know what percentages are absorbed in the soil. It obviously depends on the type of soil and the type of farm, but a large portion of that water flash floods off the land and ends up in those rivers. And so the river level will jump very, very quickly in these types of landscapes. And actually, that force of the water causes the water to move at a higher volume than it normally should. So it goes higher up on the banks than it should into areas that are not stabilized and used to having water erosion. The force of the water is dramatically increased because there's a massive volume of water, whereas the water normally would have been a lower volume. So there's more erosive force, and you get habitat like wetlands, like coastal ecosystems, all being eroded and washed out by these flash floods that then puts debris in the river, which causes more destruction on habitat throughout the river system, and sediment in the water, which causes turbidity, which is a pollution of the particles suspended in water, makes it all cloudy, right? If you look at a muddy puddle, it's highly turbid, it's very cloudy, and that can kill off a lot of different fish. So all of a sudden, if you have a huge dump of water into a river, there's multiple trickle down effects, sorry for the pun, that are going to happen that are negative in the development of that ecosystem or the impact of that ecosystem. So let's now look at that hard landscape like a city or a garden or a farm where we put in water harvesting structures. So a swale on a farm that is going to bring that water, or even keyline, which we'll talk about in earthworks, which is going to grab that water and put it in the ground just like the trees did, right? Slow the water down, sink it into the ground, and store it for later. These are the three S's of water. Some teachers say the four S's. You want to slow it, stop it, sink it, and store it into the ground. And that will slowly bring up the water table, just like the forest did. In a city situation, well, we have all of these rain gardens, which are slowing the water down and sinking it into the ground and storing it for later use. We have our parks, which can be designed as ephemeral lakes and ponds so that they capture and hold this water. And during the wet season, there's little lakes and pond habitat that come up. And then throughout the summer, it's more like a dry wetland. So there's all kinds of benefits that can be achieved. But the interesting thing is that the swale and the pond, they don't actually take water away from your neighbor who's downstream or the country that's downstream in the case of the Colorado River in Mexico. It in fact will overall increase the level of water in the rivers and the lakes because we are increasing the buffer or the storage mechanism, which is that groundwater. And the groundwater is what gives the river its water in the first place. So if we increase the bank account in the ground of the water, the overall flow of the river is long-term increased and sustained. And you can actually take areas of the world that have been deforested and you can see them, the rivers have dried up and died. And you just have these valleys. And what you can do is you can go and reforest that area and see the rebirth of those river ecosystems. Or you can swale that area, and while the trees are waiting to be grown and slowly taking their place, you can see the rejuvenation of that groundwater aquifer system very, very quickly. A little anecdote on that is that when Geoff Lawton bought his property Zaytuna Farm in Australia in 2001, he was observing the landscape and planting different climates. There was one area that was the driest area on his farm. And he planted, I remember working in that area because we were moving chicken tractors and it was just muddy muck everywhere. And I was asking him, I'm like, why is the olive and the pomegranate planted in this swampy area? And he kind of looks at me like the lessons you learn in life. Well, this was the driest area of his entire property. When he arrived, and he's like, great, so this is my microclimate, dry or desert climate, so I'll put in all my drought tolerant species there. And then swale the property, 3 kilometers of swale above that, and many, many more thereafter. But basically that caused the recharge of the groundwater ecosystem, groundwater table, and that reconnected or reinitiated the flow of a groundwater spring that comes out at that exact spot where it's incredibly dry. So it's incredibly dry there now because that spring was stopped because of the deforestation of the fields above it. And that was a really kind of ironic design fail. They ended up being fine because of the way they were designed or planted. But the irony was that some of the driest parts of your property actually may have been wetland ecosystems that have now been deprived of their natural flow of water simply because the forest is gone. And the fastest way to reinvent and reinitiate that connection to the water cycle of slowing the water, sinking it into the ground, and redistributing to all the features is by creating swales or keyline or other capture and storage systems that will recharge the groundwater table. Remember, side note, swales are not only for soakage, they can be also for flood prevention, and we'll talk about that in the earthworks section.